Welcome to Who Shaves the Barber, a weekly podcast where we explore paradoxes, thought experiments, and other pointless problems. I'm William Nava. And today we're going to talk about the liar paradox. So, if you know anything about paradoxes, my guess is you've heard of the liar paradox. You maybe have gone through the kind of little thought experiment that it presents. What I want to do today is present a fairly thorough introduction to the paradox. I'm not actually going to go over any of the proposed solutions to it with any detail, only because the liar paradox really is a whole world. If you consider it of a kind with certain other paradoxes, then it's the paradox that's gotten the most attention in the 20th century. It's actually fairly ridiculous how much ink has been spilled over the liar paradox. So I'm going to introduce it, explain kind of how it works, and the main thing I'm going to focus on for today is that there's a family of liar paradoxes, right? There's a family of paradoxes that all seem to be of a kind with the liar. So I want to see what are those other paradoxes, and more importantly, what makes them of a kind. The idea being that maybe that we can get at the underlying phenomenon that seems to be creating these liar type of paradoxes. So let me jump right into it. The paradox: this sentence is false. That's the paradox. And what makes it a paradox? Well, you ask yourself, is this sentence true or is it false? It's got to be one of the two, right? So if it's true, then what it's saying must be true. And what it's saying is that it is false. So it must be false. And so if it's true, it's false. Okay, so then it must be false. But if it is false, then what it's saying must be false, and meaning not true. And what it's saying is that it is false. So it can't be false. It must therefore be true. So if it's false, then it's true, right? So we've run through both possibilities, and we've seen that if it's true, then it must be false. And if it's false, then it must be true. Whichever it is, it's got to be both. Okay, that's a contradiction and not allowed. The world blows up. Oh no, what do we do? Very quickly, I want to run through some historical background. I don't want to focus on the history of it. It's a fairly complex history actually. But the oldest version that I know of is the Epimenides paradox, and sometimes the liar paradox gets called the Epimenides paradox. In the way that it was originally presented by Epimenides, it's actually fairly different. It's actually not a paradox. So the original Epimenides paradox goes back to about 600 BCE, and it says, there's a Cretan, a person from Crete, and he says, all Cretans are liars. So the idea being, okay, well then if all Cretans are liars, and the person who's saying that, since he's a Cretan, must be lying, so the content, you can see how it's sort of going to run through the same thing, except that this version, the Cretan version, does leave us a way out, right? It's actually possible that only some Cretans are liars, that the Cretan speaking is one of them, but that not all of them are liars, right? In that case, then that sentence being spoken by the Cretan is false. It's not actually the case that all Cretans are liars. It's only some of them. But then, okay, it's false. The guy's lying. That doesn't then lead to it necessarily being true. So we don't have a paradox. The original, the actual liar paradox, the paradoxical version, gets created by a guy named Eubulides. I don't know if I'm pronouncing that right, but another Greek, comes around 400 BCE, and is responsible for a couple of other famous paradoxes, including also the Sorites paradox, which is one of my favorites, and one that I'll definitely also be doing a few episodes on. So the liar paradox, it's invented by some Greeks, and it has some level of interest during the medieval period. Also, there's some ancient Indian and Islamic philosophers that pay some attention to it. During the kind of early modern era of philosophy, Descartes and Locke and Hume and all those guys, they don't seem to pay much attention to it as far as I can tell. I don't know of any case actually of them paying attention to it. Maybe it's mentioned. But it gets mostly ignored until around the late 19th century. So around the late 19th century, you get a guy named C.S. Peirce who starts paying attention to it. C.S. Peirce is one of the people who starts to develop a formal system of logic around that time. It ends up being not quite as influential as the system of logic created by another guy named Frege. Won't go into a whole bunch of detail about that, but C.S. Peirce has some interesting things to say about the paradox. He's kind of interesting because his proposed solution changes a few times. But when the paradox really becomes a big deal is when Bertrand Russell discovers his Russell's paradox and also makes the connection and realizes that his Russell's paradox is of a kind with the liar's paradox. So that the Russell's paradox ends up being something huge in the history of Western philosophy. Without going into too much detail, because I'll probably do a separate episode on Russell's paradox later on, but there's this sort of project to build mathematics from the ground up using logic as its base. And Russell's paradox, which I'll explain a little bit later, essentially destroys that project, and so becomes the focus of a lot of attention as people are trying to get around Russell's paradox in order to be able to salvage this project. And when that happens, again, Russell realizes that it's of a kind of with the liar's paradox, so people notice the liar's paradox as well. And then even people who aren't necessarily working in mathematics but are interested in things more like truth and philosophy of language, they start to pay a lot more attention to the liar's paradox. So that's roughly the history of it. I think it's fair to say it remains unsolved, or at least that there's definitely no consensus regarding what the best solution is. So why does it matter? Let me put why it matters in the following way. There's two laws of logic called the law of excluded middle and the law of non-contradiction, and they're considered fairly fundamental. They're considered kind of two of the three kind of fundamental laws of logic. And so the law of excluded middle says that any sentence of the form P or not P has to be true, right? So it's always going to either be the case that, a proposition is either true or false. It can't be neither, right? The law of non-contradiction comes in and says it can't be both. Right? So one says it can't be neither, the other says it can't be both. The liar paradox, one of the possible results of the liar paradox is that one of those is not going to be true. That either law of excluded middle is going to fail or law of non-contradiction is going to fail. So, if you're somebody who cares about the logic and about philosophy of language, that's going to be a fairly huge result to discover that actually there are some propositions that are actually saying something, and for which it is not the case that it's either true or false, or for which it's the case that it's both. So that's one possible result that we could get from the liar paradox. Another is has to do with what's called the t-schema. So the t-schema is a very simple idea, and it's an interpretation of what truth is. And the sentence that always gets used to explain the t-schema and ultimately what truth is snow is white, right? That sentence, snow is white, is true if and only if snow is white. If snow is actually white, right? So essentially, that's a way of saying something that seems almost trivial, right? Which is that a proposition or a sentence is true if and only if the thing that it's actually saying about the world is in fact the case. So another way to maybe deal with the liar paradox is to have an idea of truth in which it's not so simple. It would be one way of avoiding the paradox, to have essentially a more complex idea about what truth is. Another possible result of the liar paradox is that it could be that it's actually not coherent for sentences that involve self-reference to be meaningful, right? So it could be that because the liar sentence talks about itself, that makes it not meaningful, not actually saying something, okay? Of those three results that I mentioned, so either we abandon one of those two laws of logic, or we have a different conception of what truth is, or we disallow self-reference, one of those is probably going to have to be the case. And that's what's at stake with the liar's paradox, and it is, I think, that all three of those seem fairly compelling. Maybe I should say a moment about the third option. Maybe that one doesn't seem so compelling, but consider, for example, the sentence, this sentence is in Japanese. That really doesn't seem paradoxical, right? That seems very obviously false. That sentence is not in Japanese, that sentence is in English. So to say that sentence is actually not meaningful, not saying anything, it seems to me like a tough sell, right? How could it not be meaningful if it seems so obvious what it's saying? And in fact, we can determine whether it's true or false what it's saying. It's false. So that is a fairly tough thing to give up. That idea that, it is possible to have meaning that is self-referential. So in the previous episode, when I talked about logic and paradoxes and how they work, we talked about the fact that there's always three ways out of a paradox, and it is we deny a premise, we modify some rule of reasoning, or we accept the absurd conclusion, right? So in this case, to put it in those terms, denying the premise in this case is really denying the premise that this is actually a sentence. And that's probably going to go the route that says this sentence is either not grammatically well-formed, or it is grammatically well-formed, but nonetheless there's something about it that makes it not be meaningful. Okay, that would be the rejecting the premise option. And then the change the rule of reasoning option involves either a different conception about what truth is and how truth works in reasoning, or again rejecting one of those laws of excluded middle or the law of non-contradiction. And then finally, actually in this case, accepting the conclusion amounts to rejecting the law of non-contradiction, right? It amounts to that because it means accepting that the sentence is both true and false. So those are our options. Again, I'm not going to go into any of them with much detail today, only because today's kind of introductory, and I want to get a stronger sense of what this paradox really is and what's going on before we dive into the solutions. I've mentioned that there's variations, and there are. So first, a quick one. I am hereby lying. Why is that different from this sentence is false? Well, I think what's different about it is that I can make more sense of that as an assertion. So one possible solution to, which I think kind of misses the point, but nonetheless, there's a possible solution to the liar paradox, which is just like, what is this weird sentence floating in the ether, so-called talking about itself? Sentences are not agents. They cannot talk about anything. People say sentences. So what this sentence is, it's not real in some sense. Why are you worked up about it? I suppose that would be a variation on the meaningless solution. But I think if I put it as I am hereby lying, in a sense, it seems more like an assertion, right? That somebody might say. I might still wonder, why is somebody saying that? But now it's not just a sort of abstract sentence talking about itself. It's actually a person saying something about what they're doing in that moment, right? And yet you run through, it's exactly the same paradox. So I do like to point out, for anybody who has trouble with just how abstract it is, maybe that makes it a little bit more real. Another version is the circular liar. So the circular liar, I like calling it the loopy liar, it goes like this. The following sentence is true. Then the following sentence is, the preceding sentence is false. So if you can kind of see that it's the same loop, it's just an added step. So if you follow it, it's, the first one is saying the following sentence is true. So if that one is true, then the next sentence has to be true. What the next one is saying is that the preceding one is false. So that makes the first one actually false. So if the first one is true, then it has to be false once we get around the loop. Okay, if it's false, what it's saying is that the next one is true, so the next one must be false. And what the next one is saying is that that first one is false. So since it's false, what it's saying must not be true. So that first one can't be false, it must be true, right? So if that first one is false, again, once we get around the loop, that means that it's true, okay? So exactly that same liar loop, it's just taken an extra step. Notice that this, in a sense, would seem to avoid self-reference, but obviously not really, right? It's like a boomeranging self-reference, right? It achieves self-reference by pointing at something else that then points back at itself. So it's a circle of self-reference as opposed to this direct self-pointing thing that the standard liar does. And then there are the strengthened liars, sometimes called the revenge liars. So what's going on here is that certain solutions to the liar paradox, particularly the solutions that either try to get rid of the law of excluded middle or try to get rid of the law of non-contradiction, something interesting happens where it seems like you've gotten out of the paradox, but then you can make a slight modification to the paradox and it pops up all over again. So the most common strengthened liar is, this sentence is not true. Now, at first glance, that might seem like it's not different at all from this sentence is false. But here's why it is different. So let's say that I propose, well, look, the way to solve the paradox is that you're only considering two options, which is that it's true or that it's false. What if it's neither? What if there's a third way? And maybe that third way is that it doesn't have a truth value, or maybe that third way is that it's got some third truth value that isn't true or not, and is not false, some other one. Now, what that would look like and what that would mean, what the repercussions of that might be, let's put that aside for the moment, and let's just see if it actually works. Well, at first glance, it might seem like you can get out of it because you're not stuck in that loop anymore of, if it's true, it's false, and if it's false, it's true, because we've got a third option. But here's what happens. Let's now do that with this sentence is not true. Okay? So the sentence is not true is if we accept this strategy that avoids giving it true or false, then it's not true, right? This sentence is not true. It's not false either, but it's not true, right? Which means that what it's saying is true. It is not true, right? So that would make what it's saying true, which would make it true. And of course, if it's true, then what it's saying has to be true, which means that it is not true. So you're back. Even by trying to give it a third way, you still get stuck in a loop between that third option and true. Now, what if instead of attacking the law of excluded middle, we attack the law of non-contradiction? So we say, let's just accept that the sentence is both true and false. Well, now you can create a strengthened liar for that situation, for that approach, where you say, okay, let's instead have the sentence, this sentence is only false. Okay, so now this is a sentence that's saying of itself that it's only false. And in other words, it's specifically saying it's not also true. Okay, so if this sentence were both true and false, well, actually, no, it would only be false because it's saying that it's only false, right? So there would be no truth about it. But then if it's only false, then what it's saying is true, and so then it would be true as well as false, right? So then, again, we've got a way of bringing the loop back by modifying the sentence in that way. Now, it's not necessarily clear that these strengthened liars really work to decisively shut down these approaches, particularly that second one meant to shut down the approach that rejects the law of non-contradiction. It's not clear that that really works. And so, those are things that I'll look at when I do episodes that are specifically about the solutions. But for now, this is just to make that point that there is this phenomenon of strengthened liars, of liar modifications that come up as a way of addressing these these approaches. Now let's look at what is it that makes a liar paradox what it is, right? What is the fundamental structure going on? Intuitively, it would seem to be that there's self-reference combined with negation. I want to say a little bit more about that. It seems to be that we've got a situation where there is this need for self-containment. So the self-reference part seems to be the really troubling part. And it has to do with this idea of something having to contain itself in its entirety and also say something else about itself. What do I mean by that? So let me put it in a different way. I'm going to put it in a way of an abstract collection. So let's say that you have a collection. It's just an abstract collection of things, right? And in this abstract collection of things, you have in it itself as one of the things that is in that collection. So it's a collection of a bunch of things, including itself. Now, in itself, right, is included all of itself, including the other stuff that's in it, plus itself as well. So what we've created is a sort of infinite loop of something inside itself, inside itself, inside itself, but in all of those cases, also having something else in there as well. So there's something that seems to intuitively be really off about that. So for anybody out there who's into film, a film that I really love and that I think really conveys this really well is the film Synecdoche, New York. Okay, so this is a quick little tangent. In the film Synecdoche, New York, there's a playwright who is creating a life-size model of New York in a theater that's in New York, right? So in his theater in New York, he's doing a full replica of New York, full size, right? So that's obviously impossible because the theater is in New York, right? And in his replication has to be a replication of the theater itself, right? So we've got this sort of loopy thing that's going in itself, in itself, in itself. And again, it has to both contain itself, but then also have some other stuff, right? The other stuff that's in New York, presumably. So this intuitively seems to describe a bit of what's going on with the liar, right? The liar wants to have itself as its subject, right? So it wants to have as its subject, this sentence is false, that sentence. But then also wants to say something about it, right? But what it says about it is already included in it, right? So it seems to have that same structure or pattern of containing itself entirely, but then also saying something about itself, which would seem to need for it to both be kind of in itself and out of itself. Now, it's not as easy as then to say, okay, so anything that has that self-referential property is going to be paradoxical, right? Because the sentence is in Japanese, again, has that same thing where it's pointing at itself and then also wanting to say something about itself as well, right? But it's not paradoxical at all. It's a simple sentence that's just false. So that's a kind of a way of intuitively getting at what's going on in the liar paradox, but obviously more needs to be said. So in order to say more about it, I want to talk about Russell's paradox, which certainly does seem to be of a kind with the liar paradox. Before I talk about Russell's paradox in detail, I do want to make a bit of a disclaimer, which is that Russell's paradox is a set theoretical paradox. It's specifically framed in the language of set theory. Contemporary philosophy tends to be framed in set theoretical language a lot, especially logic. And that is not uncontroversial. There's something first of all, there are aspects of set theory that are really counterintuitive, and the reason that they are is that they've been modified to be able to avoid Russell's paradox. But what they've had to give up in order to avoid Russell's paradox is a sort of intuitive sense of appealing to our intuitive notion of just an abstract collection as what we mean by a set. So all of that is just to say that I'm going to be talking about classes, okay? It's really just another word for a set, but I'm talking about it in the naive sense, which is just abstract collection of things. It could have anything in it. For any kind of category that you come up with, you can say the class of things that that category applies to, or that property applies to. And so when I say class, I'm not necessarily trying to appeal to formal set theory as it is understood today. Okay, so Russell's paradox. Again, it starts with this idea of a class, an abstract collection of things that you can put anything into. So for example, I can have a class and put into it Zeno, Achilles, the tortoise, and Irene the cat. And that class has 4 items in it. Or, for example, I can make a class and define it this way, say the class of all red objects. Okay, and now we've got a class that, depending on what you count as red and depending on what you count as objects, is going to either be infinite or just have a lot of things in it, right? So Russell's paradox starts with the idea that you can have classes that can have classes in them, right? So a class is an abstract object. You can put it in a class. Why not? So for example, you can have the class of all classes as an example. And that has a bunch of classes in it. That's all, actually, classes is all that it has in it. And notice that the class of all classes is a member of itself. Why? Because it itself is a class. And since it has in it all the classes, well, then it's got to be a member of itself. So we've got this idea then of self-membership, of classes that can have themselves in them. So, for example, you could also create the class of all classes that are members of themselves, or you can create the class of all classes that are not members of themselves. And that class is the paradoxical class. That is the Russell's paradox class. Why? Because you can ask, is that class itself a member of itself? Does it belong in itself? And you can do the reasoning, right? If it were a member of itself, then it would have to not be a member of itself, because this is a class only of the non-self-membered classes. Okay, so then maybe it's not self-membered. But if it's not self-membered, then it meets the sufficient conditions for being in the class. And so it would be a member of itself, right? So if it's not self-membered, it's self-membered. And if it's self-membered, it's not self-membered. We've got the traditional loopy liar type contradiction. Okay? So that's Russell's paradox. I want to make a quick observation, which is that you can create the exact same paradox, Russell's paradox, using properties instead of classes. So really, classes are largely used as a way of defining all of the things that have some property. So for example, when I said the class of all things that are red, that is a way of having an object that has all the items in it for which the property red applies, right? So there's a sort of relationship between classes and properties. And so that means you can create the same paradox using properties as well by having the property of being non-self-applicable, right? So properties can apply to things. Something can either be red or not. So the property, for example, of being a property is also a property. The property of being a property is itself a property. It's a self-applicable property, right? And so by having the property of being non-self-applicable, you can create the same Russell's paradox. Okay, let me change gears for a moment and move on to what's called the truth-teller paradox. So here's how the truth-teller paradox works. This sentence is true. Is this sentence true or false? Okay, the way this one works is If the sentence is true, then what it's saying is true, and so it's true. If the sentence is false, then what it's saying it must be false, and what it's saying is that it's true, so the sentence must be false. Okay, so in this case, we have a sentence where if it's true, then it's true. If it's false, then it's false. We don't have a contradiction. What we do have, though, is we do still have a problem. What's the problem? Well, again, if we accept the law of excluded middle and the law of non-contradiction, then it's got to be the case that the sentence is going to be either true or false and not both. How do you decide which one? Right? Both seem to be equally valid possibilities, and it doesn't seem to be possible that we could ever learn anything that would tell us whether it's true or it's false. But it's got to be one of them. Right? So what this paradox is getting at is the idea that there's got to be something that makes something true and not false, or false and not true, and yet it seems impossible for this sentence to have that. Now, there's an obvious sense in which this sentence is similar to the liar paradox, in that it's a self-referential sentence talking about truth, right? And it's literally the same words, except it just switches false for true. But then there's a sense in which it's actually quite different. It doesn't involve negation and self-reference, right? It involves self-reference and kind of self-affirming. And it doesn't involve that loopy contradiction, right? It doesn't involve a contradiction at all. So should we consider the truth-teller paradox also in the liar family? So let me take a step back for a moment and ask, why should this matter, right? Why do we care what counts as being in the liar family and what doesn't count as being in the liar family? Why can't this maybe just be an extended family? And the answer is essentially that we have this thing called the principle of uniform solution. Okay, so the principle of uniform solution says that for any two paradoxes that are in the same family, that are of the same kind, that share a structure, they should also have the same solution, right? The idea being it's the same phenomenon that's causing the two paradoxes, and so we should have the same, if a solution is going to work, it should address that underlying phenomenon, and so it should be able to tackle all the paradoxes in the family. That's the idea behind the principle of uniform solution. And that concludes today's episode of Who Shapes the Barber? Next week, for part 2 of this liar intro, we'll explore the principle of uniform solution, dive into a technique for identifying the structure of liar-type paradoxes, and explore one of C.S. Peirce's solutions to the liar. Again, I'm William Nava. You can check out other episodes, as well as my other philosophical and artistic work at williamnava.com. And if you'd like to subscribe to this podcast, go to williamnava.podbean.com/feed. Thank you so much for listening.